Good morning, dear friends. So in chapter 3rd, that is organic qualitative analysis, this qualitative analysis of organic compound, for this chapter we already complete 2 videos. So this is the last part of this chapter, 3rd video. So we consider this introduction part, types of organic compound, 4 types. So these are the 7 steps for analysis of organic compound. So this is the determination of nature, type determination. These are the reaction behind type determination, separation of mixture into 2 components. So this is the technique used for separation of liquid from the solids, or separation of 2 liquid from each other. So this solid liquid is separated, these 2 liquids are separated by using this micro apparatus, that is round bottom flask, Hickman head, and these are the condenser which shows circulation of self water. So this is the micro kit for separation of liquids from each other, or separation of liquid from solid. So this is the micro kit. So today's lecture we consider this distillation in larger volume, large apparatus. So this crystallization is a process for purification of solid. This is the technique. This sublimation, so this technique we use in laboratory. We also have one technique which is considered in today's lecture. So sublimation, that is substance when heated is directly goes into vapor state, and this vapor is cooled down, it get converted into solid. So this is the distillation technique by using this micro kit apparatus. We consider the same technique by using different apparatus now. Melting point, boiling point. So we take this melting point and boiling points of our organic substance. When it is in solid nature, melting point; liquid in nature, we take its boiling point. Then we go for individual analysis, type determination, preliminary test, saturation, unsaturation, aliphatic aromatic test, element detection. So we go for the test for nitrogen, sulfur, halogen, and this last is the phosphorus test. And finally we go to the conclusion part. So this conclusion may be one of this group. If our extra element is absent, or element detection is group first, that is substance containing only CHO. If it shows the extra element as nitrogen, sulfur, nitrogen, halogen, phosphorus, then this respective group number is present. And this is the last part, that is the functional group test. So with these atoms or groups of atoms that define the structure of particular family of organic compounds. What is functional group? It is a combination of atoms or groups which determine the particular family of organic compound, and the same time that determine the properties. That combination gives the properties of that organic compound. That type of group is called as a functional group. So what is this functional group? It is a group of atom or compound. This is a group of atoms or a group of atoms that determine characteristics of that compound, properties of compound, called as a functional group. So it is also possible to that this compound contain 2 or more identical or different functional groups. For example, polymeric functional groups. So in this case we consider some of the major important functional group for identification. See, in element detection we consider this group of atom or group of elements is divided into 5 groups. In first group there is no extra element, only carbon, nitrogen and oxygen is present. So for this first group we have the combination of atoms to find out this functional group. If our type of compound is acid, then we take the acid containing CHO element, so we take this test only. For acid we take substance, we add this sodium bicarbonate. What happen? Carbon dioxide is released. We observe this bubbling of appearances of carbon dioxide, and we get the clear solution, and this clear solution is reprecipitated by HCl. So these are the reaction behind this. At that time we say carboxylic group is present. See, in this CHO, second test is we take this substance esterification test. dry test tube, add this alcohol, 2 drops of concentrated sulfuric acid, warm it. If you get this fruity smell, this fruity smell is due to the presence of ester. So this acid react with alcohol to form ester and get fruity smell. So what we confirm? We confirm this carboxylic group as a functional group. So this is the group of atom. Third, AgNO3 test. This substance in dry test tube, add alcohol, shake it well, clear solution is obtained, 2 drops of AgNO3 is added. At that time, white precipitate of silver salt is obtained, carboxylic acid. So this, when we add AgNO3, this combination gives silver salt of acid, and we confirm this carboxylic group. See, our element is CHO, but our type is phenol. Then we take directly test for this phenol. We don't take this test for acid. If acid is present, we take the test for only acid. If phenol is present, we take the test of only phenol, not for acid. Suppose now our substance is phenolic in nature, so we take this test in first group. NaOH test. Substance plus 10 drops of NaOH, shake it well. What happen? Completely soluble and represented by HCl. Then phenol is present. What happen? So this is same we consider for type determination. Phenol is converted into salt and then again reprecipitated. Second test is Apcl3 test. Take substance in dry test tube, add alcohol, 2 drop of Apcl3. So we get such type of complex. This complex gives blue or green or violet coloration. So simple phenol is present. No coloration, these nitrophenols are present. And the third type of nature of substance is neutral. Substance containing CHO element, but now this no acid, no phenol, it is a neutral type of substance. So there are 3 types present in first group. Either substance is acidic in nature, or substance is phenolic in nature, or either neutral in nature. So this neutral type of functional groups are divided into these different categories. It may be aldehydes, it may be ketones, it may be carbohydrates, it may be ester, it may be alcohol or hydrocarbons. So see one by one of this family, this group of compound showing this type of functional group, and all these functional groups are considered as a neutral type of compound containing CHO element. See aldehyde. This aldehyde Caro test. This Ship's reagent is taking. In this Ship's reagent we add a substance, shake it well. What happen? This aldehyde this aldehyde combined with this Ship's reagent to form such type of conjugated compound and gives a pink coloration. A pink color is present, these aromatic aldehydes are present. This Tollens reagent is taken. In this Tollens reagent we add substance, warm it. What happen? This our aldehyde is oxidized to acid in presence of Tollens reagent. It is a mild oxidizing agent. At the same time it gives precipitate of silver as a silver mirror test, and at that time we say this aldehydic group is present. Third is a failing solution, Benedict's test, also known as a Benedict test. Take substance, add water drop, 10 drops of failing solution and warm it. This red PPTs of cupric oxide is formed. When it is formed, when this failing solution oxidize this aldehyde into corresponding acids. So copper 2 plus salt is present in this Benedict solution or failing solution. When this so this is again mild oxidizing agent. It oxidizes only aldehyde to its acid, and at the same time this cupric oxide is formed. We say this aldehyde is present. If aldehyde is absent, this B, that is the second type of compound, is it may be carbohydrates. This is the formula for carbohydrates. So for that we take this Mollis test. These carbohydrates are water soluble solid. If it is a water soluble solid, we take this Mollis test. Take substance, add 2 tea drops of alpha naphthol, shake well, then we add 1 ml of concentrated sulfuric acid or warm it. What happens? See, this alpha naphthol when we added in our substance, what happen? In acidic medium it forms such type of complex, conjugated complex, and this complex shows this reddish violet coloration. So this is our substance group, glucose, carbohydrate as a glucose, and this substance shows reaction conjugation with this alpha naphthol and gives this violet red coloration at the junction of 2 layer. We say this carbohydrate present or glucose is present. See, if we go for this organic qualitative analysis, this 7th step is a literature survey for melting and boiling point. So that part, this 7th step is considered here also. If initially we take this melting point of solid, boiling point of liquid, if our melting point is matches with this 146 and our substance is carbohydrate, then it is a glucose. If our melting point, this powder shows melting point 105 and carbohydrates group is present, then it is a fructose. So this is the literature survey. This literature survey is the standard, and we match our melting point, boiling point with this literature survey simultaneously with functional group test. See, this is the B part. Now C, ketones. See, aldehyde A, aldehyde is absent, B, carbohydrate is absent. Then we take this test C for ketone. CHO element neutral in nature. So what is the functional group test? It may be solid or liquid. Take this 2-3 drops or small amount of solid, add 4 drops of solid nitroprusside, sodium nitroprusside, add NaOH and shake it well. What happens? See, if our substance is ketone, when we add this sodium nitroprusside in presence of base, it forms this type of compound. This red coloration of this complex is formed, and when this red color complex is observed, we say ketone is present. And again, if ketone is present, we match that melting point if it is solid, or boiling point if it is liquid, with this literature survey. If boiling point is 56, it is acetone. If boiling point is 202, it is acetophenone. 80, that is ethyl methyl ketone. If melting point is very low, 50, then that solid is a benzophenone. So these are the literature survey. See, A, aldehyde is absent, B, carbohydrate is absent, C, ketone is absent. Then we go for the D, that is the ester. What is the functional group test? These ester are liquid in nature and water immiscible. There is a 2 layer, water layer and ester layer. See, what is the test? Phenolphthalein test. This phenolphthalein is an indicator which shows pink color in basic medium. So same property used here. We take 2-3 drops of substance in water, add 1 drop of phenolphthalein, very faint phenolphthalein, very dilute NaOH till a pink color disappear. Till pink color appear. Very dilute NaOH. See, this phenolphthalein gives pink color with base. So we use very dilute NaOH. And then heat this tube, and then we heat that solution. What happens? If ester is present, in presence of base, is ester undergo hydrolysis to form a acid, and that acid is react with NaOH. This NaOH is very low concentration, very dilute solution is used, and when this acid is formed, that acid consume that NaOH, and if this NaOH is consumed, this basicity of solution is decreased or low, and this basicity goes on decreasing, and acid formation increase the acidity, and thus the solution do not show basic property, and thus this pink color, which is due to the basic nature of solution, is become colorless. This phenolphthalein color is due to NaOH, and when we hydrolyze ester, it form acid, and this acid react with NaOH to consume NaOH, that is, this basicity is decreases and this pink color is disappear, and at that time we say this ester group is present. Which ester is present? That liquid boiling point matches with this standard. And the last is E. If A, aldehyde is absent, B, carbohydrate is absent, C, ketone is absent, D, ester is absent. Now we use for this neutral substance may be alcohol, E type. Alcohols are liquid in nature. We take 5-6 drops of substance, that is alcohol, add small piece of dry sodium, close this mouth tube. What happen? This alcohol react with sodium metal to form a hydrogen gas. The sodium react with alcohol to liberate hydrogen gas. If hydrogen gas is liberated, alcohol is present. Which type of alcohol? We match that boiling point with this standard. Yes, if E is also absent, then we go for the F. What is F? Hydrocarbon. If A to E, no any functional group is present, then we say directly this F type, that is hydrocarbon is present. And for this hydrocarbon, we match this solid with this standard melting point. Which hydrocarbon we choose from this selected melting point. So this is the finding out the functional group of first element result, that is substance containing CHO element, and that type of functional group we find till this now. Then we go for the second type of elements, second group of element. What is second group of element? Substance containing CHO plus N. This nitrogen is present. If nitrogen is an extra element, then this compounds is classified into four types. It may be nitro acids, nitrophenol, bases, or neutral. See, among these four we have only one, because we initially determine the type and element of that solid, liquid, or organic compound. If our organic compound is acidic nature, nitrogen is present, then we take test for only nitro acid. If our substance is phenolic in nature, nitrogen is present, we take directly this nitrophenol test, not acid, no base, no neutral, only nitrophenol. If our substance type is base and nitrogen is present, see, if base is present, nitrogen must be there. Nitrogen present, आलाच पाहिजे. At that time we take test for only bases, no these three. If our substance is neutral in nature and nitrogen is present, then we have this group of element as a neutral. See, we see one by one. In theory part we see all the tests in detail, but in practical there is a presence of only one in this second class. First is the nitro acid. So test for acid as same as that of acid functional group, bicarbonate test, evaporation of carbon dioxide. Along with that we consider this neutral reduction test for nitro group. What is this neutral reduction test? We take substance, add 50% alcohol, 6 drops of calcium chloride, pinch of zinc dust, boil this solution, cool it, filter into the 1 ml tolerance reagent. So what happens is, if you boil this solution, at that time this nitro group react with calcium chloride, zinc to form this clear solution, that is, it is a clear solution. In this clear solution, when we add tolerance reagent, what happen? There is a reaction between tolerance reagent and this clear solution, and there is a precipitate of Ag. The silver is precipitated as a black or grey precipitate, and we say nitro group is present. So for, see dear friends, nitro group study, this neutral reduction test, see, for detection of nitro as a functional group, we have this test name as a neutral reduction test. Substance plus 50% alcohol, calcium chloride, zinc powder, boil, cool into tolerance reagent. We remember this test as a neutral reduction test for nitro group. If our type of functional type is phenol, nitrogen is present, then we have this nitrophenol test. See, in this nitrophenol test, very simple test, we add NaOH in our substance and shake it well. What happen? This phenol is acidic in nature. If we add base, this H plus is donated and it forms this phenoxide ion, and due to this we get this conjugation, and due to this conjugation orange coloration solution is formed. If we get this yellow color change to red, it is a nitrophenol. Again, neutral reduction test, same test as we see in acid, black or grey PPT, nitro group is present. These are the melting point, literature melting point, survey of melting point. Third type of substance, that is neutral in substance, CHO and nitrogen element, sorry, basic. If our type of compound is basic in nature, at that time nitrogen must be present. Without nitrogen there is no organic base. See, what is a test? Actually it is not a test, it is only separation of primary, secondary, tertiary amines. Amines are basic in nature. So if nitrogen is present, amines are present, and that is base is present. In this case we consider only separation of amines. So take substance, add concentrated HCl, boil, cool in ice water, and then add NaNO2. After addition of this, what happen? If yellow solid is separate out, this yellow solid is due to formation of such type of compound, that is N-nitroso compound. It shows this yellow solid at the top of tube. At that time secondary amine is present. If this reaction is not happen, we get this red coloration solution, and by addition of NaOH it become green, then this tertiary amine present. See, if you have this tertiary amine, there is no hydrogen on nitrogen, so this nitroso group is attached to ring. Nitrogen group is attached to aromatic ring, and at that time it shows such type of red coloration. If you add NaOH in this solution, this red color solution become green in nature. At that time what we say, at that time tertiary amine is present. So this compound is tertiary amine. If A and B is absent, in the same solution, what we added, we had 1 ml ice cold beta naphthol in NaOH. Basic solution of beta naphthol is added in above solution. What happened? See here, this reaction. This primary amine react with this NaNO2 solution. At that time it gives formation of diazonium salt, and this diazonium salt when react with beta naphthol in basic medium, it forms this conjugated compound. This conjugated compound is orange dye-stuff layer. It shows this orange dye-stuff coloration. See, if you add 1 ml beta naphthol in NaOH, it forms this orange dye-stuff. At that time we say primary amine is present. Which primary amine? Consider this melting point, boiling point of that substance. So these are the tests behind that. This test for nitroamine, same, this neutral reduction test. If this amine substance is yellow or orange in color, then we say this amine's basic substance shows nitrogen is present. This test for NO2 group, that is called as a diazonium test. See here, this diazonium test. Substance boil HCl, NaNO2, boil, then cold it and add beta naphthalene NaOH, we get this orange dye stuff, that is primary amine, that is NH2 group is present. And for this neutral reduction test, we have this presence of nitro group. We know this neutral reduction test. In this test, if we get black or grey precipitate, nitro group is present. Which element? That is, we confirm from this melting point. And then the last part of this second group, first part is nitro acid, nitrophenol, third is base, and the fourth is a neutral substances, CHO and N. So that group of atoms are classified in 3 different functional groups. First is a nitrohydrocarbons, amides or anhydrides. All these 3 compounds are neutral in nature. Nitrohydrocarbon. So for that again we have the same neutral reduction test as given in backside. This black yellow precipitate form shows presence of nitro group. These nitrohydrocarbons are yellow solids or liquid. If nitrohydrocarbon is absent, we go for the amide test. Very simple test. We take substance, add NaOH, boil, and at the mouth of test tube we hold this turmeric paper. If ammonia is liberated, react with turmeric paper, this turmeric paper become red in nature. Now why ammonia is evolved? See this reaction. When we add NaOH, boil it, this ammonia is evolved and formation of salt of acid. This evolved ammonia turns turmeric paper red, and at that time what we say, amide group is present. Which amide? We compare with this literature survey. If amide is also absent, then we go for this anhydride test. What is anhydride? It is a water insoluble solids. So initially we add this concentrated HCl, boil and cool. See, when we add HCl, what happens? This hydrolysis of anhydride takes place. This hydrolysis, acid hydrolysis of anhydride takes place, and it get converted into aniline. It is similar to that of primary amine. And this next stage is detection of primary amine. Then we add this NaNO2, HCl, boil, cool, acidify and add beta naphthol. At that time we get this diazonium salt and orange dye stuff. So this anhydride is detected by using primary amine test, but initially this anhydride is converted into amine by hydrolysis, acid hydrolysis, and this orange dye stuff confirms this presence of anhydride. See, we complete 2 groups of elements. Now we go for the third group of element, that is substance containing CHO. Nitrogen is present, sulfur is also present. So there are 2 extra elements, nitrogen and sulfur. For that we have only one test. We take substance in dry test tube, add 1 ml water, 2 drops of Apcl3 solution. If you observe this blood coloration, thiourea is present. If sulfur nitrogen is present, see dear student, if sulfur nitrogen is present, at that time we have this thiourea compound, and it shows blood red coloration. If our melting point is 180 degree, that confirms the presence of thiourea. See, third group of element is also completed. Now we go for fourth. Substance containing CHO plus halogen. Halogen is the extra element. We take this substance, add NaOH, boil, cool, then acidify with nitric acid, HNO3, and then add 2 drops of AgNO3. See, if white PPT settle at bottom, it is aliphatic halides. If no white PPT at bottom, it is aromatic halides. And we confirm this substance by taking its boiling point. So halogen is confirmed by using this test. See, when we add NaOH, this halide is converted into alcohol, and this salt of, so this halogen is get converted into halides, negative charge compound. This negative charge compound combined with Ag to form AgX as a white PPT. This role of nitric acid is to neutralize NaOH. So we complete 4 group of element. Now this last 5th group of element as a substance containing CHO plus phosphorus. Phosphorus is the extra element. At that time we take this substance, we add sodium carbonate, Na2CO3, and KNO3, that is potassium nitrate, and fuse this. When we fuse our substance with this compound, at that time what happen? This phosphorus is get converted into phosphoric acid. This organic phosphorus is converted into phosphate compound, this phosphate, and which then treated with concentrated nitric acid. In again we add this ammonium molybdate. At that time this phosphate react with molybdate in acidic medium to form a canary yellow precipitate of this compound. This compound is precipitated as a canary yellow PPT, and we observe this canary yellow PPT, it is due to phosphate and it is due to presence of phosphorus. So this type of compound is given is ATP or ADP. These are the ATP, ADP. This type of organic compounds are present in which we detect this phosphorus. So these are the 5 different groups of element. In that 5 groups of element we consider which type of functional group is present. So here we complete this functional group determination. So theoretically we complete this chapter, but this technique, see, in previous we see this sublimation by using this evaporating dish. Funnel is inverted on that conic evaporating dish. Now same sublimate type of solid is purified by using this cold thumb method. What is this cold thumb method? It is somewhat advanced technique. So these are the number used for their function. See, this is the outer jacket, glass jacket, in which we take this substance, impure sublimate type of substance. What is sublimate? When we heat substance, it get converted into gaseous form, directly gaseous form, and when we cool it, this gas is converted into solid. That type of substance is used for purification by using this method. We take substance in this outer jacket, it having this outer in, see this, see side arm is there for creating vacuum. This is the inner tube. We add this inner tube, this 1 and 2, these are the inlet outlet for circulating coolant. We cool this tube by circulating this coolant. This inner tube is cool, this outer tube is heated. At that time this sublimate type of compound is converted into gaseous form. This coolant tube, this gas is condensed on this cooler part of the tube, and this sublimate compound is get solidified by circulating this coolant. Circulating this coolant in 1 and 2, at the side arm is there. This outer jacket, when we heated, this substance is get converted into gaseous form. These are the sublimate material collected on the cold finger. So this cold finger is collecting this gaseous substance, is solidified and collect this sublimate type of compound. This raw product is taken in this tube. This is the vacuum part, and we separate this tube again and we remove this solid. So in this way we purify this sublimate type of compound. See, we consider distillation method for purification of liquid. If liquid containing some water part, at that time we have this dehydrating agent for purification of liquid, drying of liquid. We have dehydrating agent to remove this water molecule. So we use this calcium chloride, but it having some limitation. It is not used for alcohol, phenols, amines. Sorry, cannot use for this. Again, it cannot be used for this dehydrating of acid liquid. Another dehydrating agent is calcium oxide. It is also called as a quicklime. It is used for alcohol and cannot be used for acidic type of compound, because this dehydrating agent, it is also dehydrated ester also. Potassium hydroxide, KOH. This is third compound, particularly suitable for amines, not useful for this acid ester. This potassium carbonate, K2CO3, it is a mild compared to this potassium hydroxide. Therefore, it is used for strong alkaline dry hydrating agent. Next is powder anhydrous sodium sulfate powder, anhydrous powder. When we add it in liquid, it sucks this water. It is used for all types of liquid. This magnesium sulfate, anhydrous magnesium sulfate, it is somewhat rapid as compared to the sodium sulfate. A rapid action is there. It is also used for all types of organic liquid. Calcium sulfate, it is also dry treats. It is used for all organic liquids. Metallic sodium, particularly used for dehydrating of ether. This ether is dehydrated by using this sodium metal. So these are the some chemicals used for dehydration of liquid. See, in just now introduction we consider this distillation by using Hickman head, that is a micro kit apparatus. But here we have this large volume of round bottom flask. A large kit is there for large volume of liquid is get separated by using distillation method. A large volume of liquid is distilled out by using this distillation method. It is used for purification of organic liquids. So we have this thermometer to check the boiling point of liquid at the steel head. This is clamp, distillation flask, source. This is the condenser. We continuously supply this water to cool this condenser. And this is the receiver to collect this liquid in this receiver flask. So this is the large volume of liquid is get purified by using this distillation method. As compared to Hickman head, this is the larger assembly. Hickman head is a micro kit apparatus. Same distillation technique is here. So in this case we introduce this fractional column. This fractional column is introduced. Why introduce this fractional column? For separation of liquid having very low difference in boiling point. Suppose for example liquid having boiling point 85 degree and second liquid having boiling point 90 degree. At that time they shows close boiling point. To check their boiling point we have this fractionating column. This length of column and inner surface area are most important for fractionating column. As the length of column and this inner surface area of column increases, efficiency of column to separate liquid is increases. For separation of liquid we use this fractionating column, and we separate liquid having close boiling point. But all apparatus are same. We hit that liquid is boiled. We check this boiling point of by using thermometer. Condenser cool that gas into liquid. That liquid is collected in this receiver. So we have various types of this fractionating column. So this ABC, these are the various fractionating column, Weigres, Widers, and this column glass beads are introduced. This fractionating column provide large surface area. Surface area increases for evaporation and condensation. And on the surface of fractionating column, the vapors of liquid condense and evaporated several times, and thus the separation is very accurate. So we separate two liquid having close boiling point by using this fractionating column. So this is the specialty of this fractional distillation. So thank you dear friends. Here we complete the third chapter of analytical chemistry, that is organic quality analysis of organic compound. Thank you dear friends.